after about 3 weeks of messing around with N8N, I would probably say I fell in love with it. I deployed my own personal instance of it to my Kubernetes cluster, and I use it for all kinds of random personal projects. I built a little crawler that watches a hotel that my wife likes that's nearby, but it's always booked out a year in advance. So I have a crawler that notifies me when rooms become available at this hotel.
Welcome to the /podcast, where we lean into the future of IT, inviting thought leaders, innovators, and problem solvers to help slash through its complexity. Today, we have with us Austin Kerpus. Austin Kerpus is a developer at Bitovi with a passion for building thoughtful, maintainable software. He's all about creating great user experiences and solving tricky problems with clean, effective code. When he's not deep in a project, you can find him sharing thoughts and side projects over at austinkerpus.com. That is AustinKurpus.com. Thanks for being with us today, Austin. So you work for Bitovi. They're a consulting company similar to Calibrity, right?
Yeah, that's correct. I've been with Bitovi for a little over 8 years now.
And you guys you're out of Chicago area?
Yeah, we're completely remote, but most of the board happens to live in Chicago, so that's where the company address is. But even the board is fully remote.
Nice. I love Chicago. Great town. So you work as on a lot of back end systems. Is that correct?
Yeah, I am one of the team managers for the backend department, so I focus primarily on backend systems these days. I try to stay away from the front end if I can avoid it.
Yeah, it's unfortunate. Like for me, I've always been a back end developer. I don't know if it's unfortunate. It's kind of fun actually, but like when I do side projects now, it's kind of boring just looking at JSON strings all the time. So I do have to kind of dip my toe in doing some UI stuff every now and then. I'm not terribly great at it, but it's fun, I guess. Every now and then, it's kind of fun to actually see something come to life on a screen instead of just some text scrolling
Oh,
by.
come on. JSON's great to look at. I think we should replace UIs with just a bunch of JSON.
Now, I'm no slouch. I do pretty print the JSON. You know what I mean? Like I do that. So it is very nice looking when it's scrolling by, just like I'm in the Matrix.
All right, but here's the question. Do you pretty print it with 2 spaces, 4 spaces, or a tab?
I think it's 2 spaces though.
All right, that's right. That's good. Two
That's
spaces
acceptable.
is the right answer.
It's definitely not tabs. I mean, come on. What are we? This is 2025. Are you kidding me?
Yeah, I think we won that battle.
Exactly. All right. So back-end system. So that's now, are you writing like APIs as a service or like API products, or are you doing like integration type? What do you get into these days?
For the majority of the last couple of years at Bitovi, I've been consulting in temporal, doing a lot of different stuff. Some of it related to agentic AI, some of it related to sort of B2B products and things like that. More recently, I've been mostly focused on consulting in the agentic AI realm, specifically building AI agents for some of our enterprise customers using no-code tools. So mostly focusing on sort of prototyping, using tools like N8N. And then longer term, I'm sure we'll move those out to a more durable solution like temporal. But that's kind of where I've been for the last 8 months or so, is really just building AI agents.
Tell us a little bit about what that is and why do you choose to use that? Why is that an effective tool for what you do?
Yeah, great question. So temporal is a durable execution runtime and platform that allows you to build resilient applications without thinking too much about the redundancy factors and what happens when things fail. Temporal is, fundamentally basically just an abstraction layer over a queue, but it's a really, really nicely designed abstraction layer that is built for a lot of fault tolerance, or built to solve a lot of fault tolerance edge cases, essentially. So you can really focus on building your application code, writing your business logic, and you don't have to think about what happens if there's some sort of intermediate failure. Maybe a worker crashes, maybe there's a intermediate network failure. You spend very little time thinking about those failure scenarios when building things with temporal as opposed to other solutions.
The workers, the things that actually do the activities that need to be done and orchestrated, those you kind of control. You run those workers yourself on your own, hardware, or in the cloud or whatever, and then they
Mhm.
kind of phone home back to temporal, and that's temporal kind of takes care of like that state management, and it knows I've got to finish this task and then go on to another one and this, but it manages that where am I along the journey kind of stuff, right?
Yeah, the temporal service essentially orchestrates everything, and then you're responsible for building and deploying your workers. So you manage all of the code, you manage the actual sort of application runtime. You build the worker using their SDK, which communicates with the temporal service to orchestrate everything, and then that actually provides a runtime uh, that offers durable execution. So essentially, as things happen, especially non-deterministic things happen in your workflow, temporal is keeping track of the state of everything as it happens. And so if there's some sort of an intermediate failure, even if a worker completely crashes and goes offline, temporal is actually able to, or the worker is able to use temporal, I should say, to replay everything that's happened up until the failure to recreate the internal application state. There is a few different primitives in temporal that you need to be careful about building around, like non-deterministic functions, for example. And there's specific ways that you need to communicate with a worker and query data from a worker. But as long as you're using all of those temporal primitives to take these actions, then the implementation is fundamentally durable. It can handle any kind of failure and pick up where it left off, no problem. The only real caveat there is things that need to be idempotent. So maybe like a payment system, you want to make sure that the API you're using is implemented in an idempotent way. You do have the possibility of, running an action twice if, say, something completed and then the worker crashed, but it wasn't able to update the state in temporal. There is a possibility that it will replay that action, or rerun that action instead of using previous state. So for things that are highly sensitive, like payments, you want to make sure to still use idempotency. But other than that, you really don't have to spend too much time thinking about failure scenarios.
And idempotency is kind of means like if you do the same thing multiple times, there's only ever going to be the basically the one outcome, and that's kind of the gist of it, right? So like you're saying for
Yeah,
payments, I don't charge somebody's credit card over and over because I had to replay the thing. I know I charge them, so I don't charge them multiple times. Okay,
correct.
very cool. Yeah, that was the thing I was going to ask about would be idempotency. That seems like that would be very important. Now, are there, not to necessarily name names, so to speak, with clients or any sort of thing like that, but the types of problems where you've thought, wow, temporal's really saving my bacon here. I'm so glad we had that. And types of problems like that that you can remember.
Yeah, I can remember many times where the same basic scenario happened on various clients over the years. But fundamentally, a situation would occur where there's some kind of a failure in production. We have workers that are blowing up. The workloads are not completing. The queue is stacking up with work, and in a traditional system, maybe if we had used SQS and had workers consuming out of that queue and things, if there was some kind of failure, the way you would typically handle that is maybe you retry it a few times and then eventually you give up and you put it in a dead letter queue, and now you have all of this stuff to clean up, and maybe you have a workflow for cleaning that stuff up, maybe you have manual processes, but you really need to think about, like, how do I get this work back into the queue to be consumed, and how do I figure out the state that everything is in. So with temporal, you can just deploy a change to your worker, and when the worker comes back up, it'll pick up where it left off, and it will resume execution. Up to the point where it has completed things, and if you implemented the fix correctly, your workflows will just complete. Right? There's no operational work. There's no cleanup. As long as you set your retries and timeouts and sort of exponential back off up in a reasonable manner, and you're able to deploy a fix in a reasonable amount of time, your workflows will just keep on moving. And of course, there are some cases where this is not a good thing, right? Maybe there are cases where you're you're working with highly time sensitive data, and
Mm.
so you need to have a more immediate failure and recognize that and not keep that work in the queue. And there's also ways to do that inside of temporal, but for the situations where it's a matter of processing what's in the backlog, it's work that needs to be done at some point, you can deploy a fix and you can watch your backlog start to drain. It's a really powerful tool for being able to solve problems in production like that.
That is cool. Yeah, I mean, I know it's funny. Like a lot of those integration projects I've been on in the past, it was like, okay, we'll just throw that to the dead letter queue. But there's no plan of like, what do you do with that stuff? Like replay is not exactly completely straightforward all the time, right? Like you're saying, there's a lot of different things that need to go on. Like there could be a bad record that's bad right now, and I need to get a software fix out to be able to address that. But there's things stuck behind it that I can process right now. Those sort of scenarios are weird. So now those failures you were talking about, is that like, those are sometimes they're temporary failures. Is that, I think we talked about like in the prep call, like third party, services or off the shelf products where you're trying to integrate with those can be problematic. And tell us a little bit about your experience with that.
Yeah, so I've definitely spent a lot of time over the years integrating with third party software solutions, and sometimes APIs are built well, they're documented reasonably well. It's I've had those experiences where it's actually honestly like a pleasure to integrate with someone's API, and I'm
Hmm.
just thrilled with the experience. I'd say more commonly it's not so fun. It's not so painless. I can think of a particular time early in my career when I was working on a SaaS product that offered products, so like back in stock notifications for e-commerce stores, right? Like there was no software as a service product out there at the time that did this. I think there was I think Magento had like some plugin you can get, but like the majority of e-commerce platforms out there had no native support for it, no plugins for it, no SaaS solution that you could just drop on your site. So we were trying to build that, and we decided to target a particular e-commerce product that we knew a lot of merchants that were very interested in this service on that platform. We had really good relationships with them already, so it seemed like a good product to target. That ended up being a really terrible mistake. It was really easy to get beta testers and even get our first few paying customers because of the relationships we had with merchants on that platform. But ultimately, their API proved so ridiculously unreliable and broken that it
Oof.
destroyed our product. We
Ouch.
could not offer a reliable experience around their API because so much of it was just fundamentally broken. Things like rate limiting didn't work. They would start denying your requests, and they would say that they would send you a header with a time delay for the how many seconds you need to wait for your request bucket to refill or whatever, and that the header would never change. It would always just say 0 seconds even when they're denying your requests. There was little things like the data structures they would return were inconsistent. Some merchants, you would have like some value would be a number inside an array, and some other merchant would just have the value in no array.
Oh my
And it's like,
goodness.
why is this inconsistent between merchants and things like that? And so it was just constant fighting their API, trying to build our like custom rate limiting stuff that would do like exponential back off when we started
Hmm.
seeing failures. And the endpoint was so unreliable that we would make the request to update the product, and then we would check again a few seconds later to see if it was updated, and if it wasn't, we would try again, and if it didn't work that time, we would fail and say sorry, it's not working right now to the end customer.
Come back
it
later.
was it's so like just trying to build this product and like make it integrate deeper with their platform was just like pulling teeth the entire way, and it ended up killing the project.
Oof, man. I mean, that's beyond any resilience patterns that, like you said, you already tried retries, you already tried, these sort of things, the circuit breakers, and that's not going to work, right? For in that situation, that's crazy. I did have an internal product when I worked at a client one time. I was kind of asking for documentation on the API, like, well, what does this return? What is the shape of this response? And they were like, well, just go read the code. So I did because I'm a developer. And that didn't really help. It did the same thing you were talking about. There were times when a field would be a scalar value, just one single value. And then there were times when it realized, oh, I need to be an array, and it would transform it into an array and rewrite it. There was no actual shape of the response, no object that held the shape. They just made it up and kind of munged in things as they needed to. So that was, yeah, I've had similar experience. That's not fun. Okay. You mentioned I do want to hear about N8N, and is it Nathan, or is it like, why is it called N8N?
It is technically called nodeamation, short for node automation, I guess. It's like node. It's like a node based or graph based um, sort of workflow builder tool. It's categorized as a no code tool, although it gets a little fuzzy because you can have nodes that implement custom code, and you can also build custom nodes from the ground up that you can sort of just drag and drop into the UI as if it's any other native node. So there is sort of the ability to write your own code and get your own code into the workflow in some senses, but for the most part, you don't really need to write code. It integrates with a lot of third-party platforms out of the box. I think they have something like 400 integrations. It definitely has its limitations. I certainly, um, I would be very careful before trying to build a product around it. I don't know. There's probably situations where it would make sense, but for the most part, if you're trying to build a product and you're shooting for like large scale and sort of multi-tenancy and all of that stuff, then you probably want a more robust solution. But if you're building prototypes to prove concepts and you're wanting to move really, really quickly, and you're building maybe one off business tools or even internal company tools, I think it's a fantastic thing to keep in mind. Like it's it's just another tool in the belt, essentially. Not always the right solution by any means, but it has immense power, and it's kind of one of those things where I was a little reluctant to use it at first because like I'm
Yeah,
a nerd. I love writing code. I
sure.
already don't write enough code being a manager now, and I was offered this project working in N8N for a while, and I was a little reluctant at first, but after about 3 weeks of messing around with N8N, I would probably say I fell in love with it. I deployed my own personal instance of it to my Kubernetes cluster, and I use it for all kinds of random personal projects and just quick, I want to notify myself when something restocks on some website. Ironic, we're going back to stock notifications, but yeah, sometimes I do custom stock notifications for sites that don't have it. I built a little crawler that watches a hotel that my wife likes that's nearby, but it's always booked out a year in advance. So I have a crawler that notifies me when rooms become available at this hotel, and it's actually worked for us before and gotten us uh, hotels under on like short notice and stuff like that. So it's a really great tool for just like hacking things together. I highly encourage people to use it, even if they don't think they have like a
Mhm.
sort of enterprise use case for it. If nothing
That's
else, it's a great
hilarious.
tool for personal use.
I was gonna ask, like, I didn't know that you were using it personally. That's really cool. That's adequately geeky. I love it. Okay. I'm definitely gonna have to check it out. You are not the first person I've heard talk about this tool, so it's definitely popped up a few times in conversation. So I'm gonna have to give it its due. And I think even like in the enterprise, these sort of tools, they do have their place, or they can have their place, and it's those. I think like the swivel chair integration, right? So I turn on enter data in one system, or I go look something up in one system, and then I swivel my chair over to another one, and I input data into another one. Those are great candidates for these type of automation tools where you don't have to write code, but it's monotonous work or tedious or time consuming, but you're not doing it a gazillion times a day or anything, but it'll save you time for sure.
Sure. Yeah, especially one-off tasks. It's like Oh, I want to get all of my sales
Mm,
proposal emails loaded into Google Docs. It's a one-time process. We're going to use Google Docs to store this going forward, so it's not going to be a problem. Throw the workflow together and edit in, run it, and then throw it in the garbage. It took you maybe 5 minutes to throw it together, and you never have to look at it again. Like, no real engineering effort there. You don't even need
that's
someone
cool.
super
Yeah,
technical to do it
absolutely.
most
Check
of
it
the
out.
time.
So you mentioned that you've lately been building agentic workflows, and we do hear a lot about that in the market right now. That's a hot topic, usually paired with AI, AI agents or agentic, multi-agent AI workflows. But agentic workflows themselves aren't necessarily AI. Is that right?
I think that pretty much all agentic workflows have an element of AI in it. I mean, well, let's back up a second here. So I think that there's a lot of marketing fluff around agentic AI. There's a lot of marketing fluff around AI in general. I define agentic AI as some sort of an automated system that is goal oriented and is
Hmm.
iteratively working towards that goal. Right? You could possibly create something that vaguely fits that description that does not use
Hmm.
AI, but I think it would probably be very hard. Like most things that don't use AI
Hmm.
are more task oriented, right? Like most problems that we solve with traditional programming, we think of as like being task based, right? Or maybe it's like a collection of tasks. An AI agent receives a goal, right? And that goal is not necessarily a task or a set of tasks. It's a broad, you're here and I
Hmm.
want you to be here. Figure out how to make it happen, right? And the agent is able to look at the problem and break it down into steps and then iterate on those steps until it comes to a conclusion, hopefully, right? And so like that's what I define agentic behavior as. And I don't think that, at least I haven't seen any examples that I truly think fit that aren't using AI under the hood. Typically you need some intelligence under there, not just
Yeah, to
traditional
have the
logic
kind
to
of
build that kind of
autonomous, you
behavior out.
figure out how to get from, like you're saying, from point A to point B. Absolutely, that's going to require some sort of smarts to it, some artificial intelligence. What I was thinking about is, like, I know folks get kind of caught up in it when they're building. I mean, because we've been doing agentic stuff, like event driven systems are somewhat agentic. You know, they're not figuring out how to do the workflow on their own, but they're processing things and they are autonomous and they're purpose built for a specific task, like you were saying. I think a lot of people get caught up in everything has to have AI baked into all the little pieces of the workflow. So, like you're saying, yes, that orchestrator, that thing that's figuring out how to get from point A to point B, that absolutely needs to be smart. But the tasks along the way, like, oh, go insert this user into a database, that can be very straightforward and hand coded type of a thing, right? So those other agents that work together or it can enlist to get the job done, those don't necessarily have to be. They can be very purpose built, and you don't need AI to write a record into a database, but you do need one to kind of figure out the flow and how am I going to get from A to B. So yeah, that's cool.
Yeah, absolutely. Yeah, I would say that most of the agents that we're building currently, I would I would describe them as being a hierarchy of workflows essentially. At a top level, you can think of the entire thing as being an agent, and then underneath that, you may have intelligent automations, you may have sub agents, and you may have traditional automations or more broadly tools that these agents are interacting with, right? And you really, at least given the technology that we have today, the level of intelligence that we're currently able to derive from these models, you have to build a hierarchy of these different workflows that sort of come together with some sort of an
Mm.
orchestrator, in some cases multiple orchestrators, to actually complete the task. And there's many pieces of that are sort of traditional automation or like deterministic functionality. I think a really interesting example of this actually is on my current client. We're building AI agents to basically write end-to-end tests in their testing lab for them. So the agent reads a ticket and it outputs code. So the really interesting thing about one of these agents that we've built that generates code is the code generation itself is completely deterministic, which really throws people off. The analysis of the ticket is where the intelligence is, right? So we analyze the human words or the English words in the ticket and understand what they're asking for and ultimately translate that into like the domain knowledge and all of the context needed, and then we take all of our analysis and we turn it into a JSON structure that basically represents all of the things that we need in a very deterministic and highly specified format. And then we take that JSON object. You can almost
Hmm.
think of it as an AST. It's a little bit, it's more nuanced and it's kind of like domain specific, but it's very similar to like an abstract syntax tree. And then we pass that into a template engine, which then writes all of the code completely deterministically. So the analysis takes like a few minutes on the ticket side, and then to generate the code, it takes like a few milliseconds. It's like almost instantaneous. So it's really interesting because a lot of people would expect that the intelligence is probably more on the other side of things, on actually writing the code. But in this case, we took the approach of using all the intelligence to understand the non-deterministic aspects of the problem and convert that into a deterministic machine readable structure that we can convert into code. And in some cases, this approach doesn't work, but we've actually had really good luck with it in other approach or in other cases. And I think it demonstrates really well that to create agentic behavior, you can have great success by mixing traditional and deterministic sort of logic with this intelligence or
Yeah,
with
that seems
many
to be a
intelligence
common
layers,
pattern. I
in
mean,
fact.
especially with generative AI, one of the great places where you can plug that in is kind of being that um, unstructured to structured bridge, like you're doing. So I give you some natural language, and it says blah 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 whatever in the ticket, and that's just people typing things, humans typing things, and then you use the kind of an LLM or generative AI to interpret that, understand the meaning, provide semantics to it, so it knows what's going on, and then you tell it, here, do some structured output for me, and make some sense of this world and give me some structure to this. Yeah, it's a fantastic pattern.
And in the case of the agent I was using as an example, the target is using a like a in-house built testing framework that our client built themselves years ago. So it's almost like a DSL built in Python. That makes it sound more complex than it is. It's more like a subset of Python, really. So it ends up being something that we can represent in a machine readable format quite easily. That's why I said it's similar to an AST,
Hmm.
but it's more nuanced and more like domain driven. Um, but it's really in this exact case, since it's like such a subset of Python that we're targeting and the structure of it is so defined, it ends up being really easy to build a deterministic template generator and sort of front load all of the processing. But in other cases, we actually do need to make the LLMs understand the code and the context and actually have the LLM produce some Python
It's
code or
usually
some
pretty good at
Java
that,
code in
especially if
some
you give an
cases.
examples. Do like kind of one shot, few shot. It does a pretty good job of that most of the time. Yeah.
It depends. It depends. I would say like things like Claude and Chat GPT are really good at it at this point. I've heard Gemini is really great too. I haven't used Gemini for code all that much. I know I need to give that a try. Where we're working right now, the client is security oriented, we'll say, and we cannot use any cloud hosted LLM providers. So we actually have to host all of the workloads in their lab on premise. So we are sort of
Mm.
limited to using open source models, and we're very limited on compute at the moment. They're working on spinning up more compute for us, but we're limited in the size of models that we can play with right now. So we're kind of limited to like Llama 3370B. Currently, the 4-bit quantized
Hmm.
version of it as well, so it's a little bit less accuracy. It's definitely more of a challenge with these models because they're much smaller context window, much smaller, or sorry, not much smaller
Hmm.
context window, much smaller parameter size. In some cases, smaller context window as well, and just generally what I perceive as lower intelligence behavior out of these models. So it definitely can be more challenging. It feels a little bit more like working with ChatGPT circa
That's a
2003.
long time ago. All right, so yeah,
Yeah,
and I
in
try
the
to make
AI
sure I go
world, that's a
back and like
century,
when we
right?
say acronyms, DSL you were talking about is a domain specific language, right? That's what you meant by when you say DSL, right?
Yeah, again, I think that was probably a poor way
I
to
gotcha.
characterize it. It's more like a subset of Python.
Yeah, it's fine.
Yeah, it's
And then
yeah.
quantize. That's an interesting approach. So with these LLMs, quantization is when you take like so if normally the parameters or the you know all the numbers that are involved are let's say 2-bit number or I mean two word or 16-bit or 32-bit or whatever, and you kind of represent them, you kind of squash them down so that they only take up 4 bits of memory or 8 bits of memory, and that's usually good enough, and it gives you good enough behavior, but it doesn't take up this big amount of memory. Is that what you were talking about, right?
Yeah, most models these days are trained at 16-bit floating point, from what I understand. That seems to
Hmm.
be what most of them are actually released at anyway. I don't know too much about the technical side of training, so I could be, maybe it's a little more nuanced. Don't quote me on that side. But at least typically you would be consuming the 16-bit quantized version of the model, and that typically means it's really large. Like for the Llama 70, Llama 3.370B, I think it's something like 130 gigabytes, right? If you're and I'm sorry, that's actually just the 8-bit quantized version. So if you're doing 16-bit, it's a lot of memory. So dropping it down to 4-bit quantization, you do lose some of the model accuracy. It's not exactly easy to understand the impacts of that, but I've seen some people quote that it's somewhere between 2 and 5%. I don't know how you even determine that, but you ultimately do lose a little bit of accuracy and performance there. But that does mean that you can run it on like a MacBook, right? You suddenly only need like, I think
Oh,
it's
nice.
73 gigs to run the 4-bit quantized Llama 70B at the 3.3 version. So it allows you to at least
Hmm.
build prototypes and validate some ideas and things like that. We'll be moving to the larger versions of the model in the near future as their lab brings on more CPU, or sorry, more GPU. But as I'm sure everyone knows right now, it's a very constrained
Hmm.
resource. It's hard to get your hands on it. They're very power intensive. The lab there had to actually bring in more power for the servers initially to even get the 6 GPUs that we have now. So it's pretty intense, the amount of VRAM that these models consume. Even the open source and what are relatively
Yeah,
comparatively
the way I
small
think of
models.
quantization, at least like the way I always like to use analogies so I can understand things. Like I think of like if you have a 4K video, but you want to, you can watch it in 720p, you still know what's going on, right? It's just not as great of an experience. It's not as crisp or whatever, but you can still see, oh, there's a person or a cat or whatever, right? Like you kind of get the idea, the gist of it. But that's kind of how I think of quantization is just kind of downsampling the resolution on a video, kind of the same idea. That's how I think of it, at least.
That's a really great way to look at it. But instead of the resolution of the pixels, you're looking at the
Exactly.
resolution of the
And it's
floating point
surprising that it
numbers.
only
Yeah.
2 to
Yep.
5%.
Exactly.
Going from like 16-bit down to 4, it's actually surprising that it's only that bad. That's pretty cool. Awesome. Now, one thing I did want to ask about is on these agentic workflows. How how's your experience been with like error handling when things don't go as planned? How is it integrating with these LLMs when they're trying to plan things out and they just run into a hiccup, so to speak? How does that work?
Yeah, it's a great question. So it really depends on the context. Um, so there's some workflows that we have that are writing code, and they actually take the code that they write and they run it in like a Python runtime, and they look at the result of that, right? And if it throws an error, then we actually just feed that back into the LLM and say, here's what you tried, here's the error we got, try again. And we iterate on that. So that's really cool. In other cases, we have much more boring workflows that are just like making calls out to Jira, and updating ticket status and things like that, right? And sometimes those endpoints are a little bit unreliable within the lab environment. There's a lot of proxies involved. There's a lot of interesting things going on at this customer's lab environment. So sometimes there's intermittent failure on their self-hosted Jira instance, and so lots of retries, exponential back off, that kind of stuff. All all pretty standard things. I will say that's one area where we're hitting a little bit of a pain point with N8N because it does not offer
Mm.
exponential back off functionality. You can have retries, you can set the interval, you can't have them back off if it's failing lots. You can't have
So
it
the
back
idea
off
there would be like
exponentially if it keeps
retry
failing,
in a
right?
second, and then if that doesn't
Um,
work, retry in 2 seconds, retry in four, retry in eight. That's what you're talking about when you talk about like kind of that exponential back off. Okay.
yeah, 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 exactly. Typically, the way I see it done is you have your maximum retry count, which is, we won't try more than that no matter what. You have your retry interval, and then you have your exponent,
Mm-hmm.
which is like basically
Yep.
you multiply by the exponent every time you retry, and that is your new duration. So yeah, N8N doesn't support that yet. I imagine it's probably coming. So that's been a little bit of a pain point for us. In the meantime, we just retry a lot because it's just the only option that we have for those third party services that are unreliable. Um, this is also something that I think longer term temporal will really shine for holding a lot of these workflows, especially since they're not really like latency isn't a huge issue for us. In many cases, we have hours to process the incoming events that we're dealing with. Some cases we even have days. So using something like temporal and having its durable execution runtime, and it has exponential back off and all that good stuff too built in. Longer term, we kind of see moving to that as a solution for some of these intermittent failures. And then beyond that, we're still very much in a prototype phase. Using all no code tools, really trying to prove concepts. None of this stuff is in production yet. We're still working with the legal team at this particular company to get authorization to actually start using it on production data and in production use cases. So we're very privileged in that we don't have to worry about that stuff too much. It's definitely something that's um, very much a concern on the horizon as we scale up and as we move into a more productionized kind of solution. But as of right now, that's really the only thing we've done related to retries
Gotcha.
or related to
Yeah, and
failures, I should
I'm
say,
trying to
rather
kind of
than
like
than
come up with
stuff.
like kind of a takeaway. It's interesting. I'm seeing like some parallels. So where the way we approach product, and again, I'm not a product person myself, but our group at Calibrity, we when we approach product, one of the concepts as we're going through, usability testing and those sort of things is you want to stay ugly, so to speak, as long as possible, right? You don't want to be in there writing really intricate code, for prototypes. You stay ugly, low fidelity, all of those things for as long as you can. You're kind of It's kind of the same concept. You're using these low code no code tools, not to say they're ugly, but it's less investment up front as you're trying to prove out ideas and those sort of things. And then as things start to take their shape, maybe you do like you upgrade to temporal instead of N8N or those sort of things. I don't want to say upgrade, that's probably a dismissive way to talk about N8N. But that's the idea, is you invest a little more time into higher and higher fidelity, so to speak, tools as you get along with your idea and prove it out a little further. Would you say that's kind of fair characterization?
Yeah, and I think that aligns really well with I'm sure you've heard the term
Yeah.
make it work, make it right, make it fast. Right? Like, yeah, that's I love that. The first time I heard that was like 8 years ago from another Bitovian when I was in training, and it really resonated with me. Um, I like to almost always default to taking that approach. We have some clients who don't like that approach, and so it's there's been times I've had to adjust, but I like to push people in that direction. I think that first and foremost, getting something out there and working that people can put their hands on is like
Absolutely.
the most valuable thing you can do. Even if it's half broken, even if it's, it's not perfect, it doesn't look pretty, whatever it is, it has
Mm,
limitations. Like, prove the concept as early as you can, start getting feedback as early as you can, start learning about how this thing
yeah, absolutely.
should and should not be designed really quickly, right? And then once you have that, then you make it right. You improve upon that, and you fix the things that are wrong with it, and you make sure that it's built in a way that is reliable and maintainable and robust and future proof. And then, if and only if you have performance concerns, right?
Amen.
Because you don't want to early optimize performance. If you have some kind of a
Sure.
constraint related to performance, then you make it fast. And so I think, N8N falls really nicely into that first category of make it work. Just get something out there, understand how the pieces fit together, understand how your data flows, because you can spend all day planning and writing up documents and building diagrams, but until you see the data flowing through your system and you see the result that you want to see, you won't for sure know that you're not
Yeah,
missing something.
I had a professor who had the same concept in college, and I remember it to this day. He talked about the three R's of software development or software engineering: make it run, make it right, make it rip. That was the way he phrased it. He had the three R's: it was make it run, make it right, make it rip. I remember it says I don't even remember who the professor was, but I do remember that lesson, the three R's. So that's pretty good. Good way to
I
remember
like
it.
that.
Good
I like that.
mnemonic, so to
Very,
speak. Our
very
next
cool.
segment is what we call the ship it or skip it.
Ship or skip, ship or skip. Everybody, we gotta tell us if you ship or skip.
How about Kubernetes? Is this a DevOps power tool or an over engineered headache? Ship it or skip it.
Ship it. I'm a really big fan of Kubernetes personally. Um, I think that it's dangerous to look at it as the de facto option for deploying things. I think there's a lot of value in other tools, like just throwing something up in an EC2 container in Docker Compose. Like
Yeah.
that's great for some things, right? And it's fast. There's all these new fancy like container first platforms like Fly.io, and they're like, give us your container and we'll run it for you. It's
Sure.
all magic. I think that's great in some ways. Um, I think that there's a lot of downsides to those approaches. Most of them are around scaling. um, I have a customer who operated on Fly.io, and they ended up reaching the point where they had something like 7,000 concurrent VMs in their production environment, and like Fly.io
Wow.
just could not keep up
Sure.
with that. Their dashboard would break, their CLI tools would just time out when trying to scale things up and down. It was a mess, and ultimately the right solution for them was to move to Kubernetes. But there's a really big there's like an ocean of difference between like a container running in Docker Compose on an EC2 instance
Mm.
and someone running 7,000 container, or
Mm-hmm.
7,000 VMs on Fly. And Kubernetes is somewhere in between, and it's probably a little different for everyone. So I could probably talk about Kubernetes all day here. I have a Kubernetes cluster in the closet of my garage, actually made of
Fantastic.
Raspberry Pis. So yeah. Long story short, Kubernetes is great. Don't be afraid of it. It's not as hard as it seems at the surface level. But also don't be dogmatic about it, and don't assume that it's always the right thing for your solution. And it's as tempting as it may be to start out on Kubernetes for the future proofness and the scalability. Uh, maybe just don't do that. Start out with something
Yeah,
way
exactly.
simpler.
Yeah, I'm with you on the Kubernetes. Like I'm a ship it. I do think it is a power tool for DevOps front. And the main reason I like Kubernetes is it's kind of like it levels the playing field. Everybody knows there's kind of this standard, right? So you have frameworks and utilities that kind of know this world, and you can leverage those and piece these things together. So I do like Kubernetes for that. Okay, any final thoughts or advice that you would want to share with the audience?
I would just say this kind of falls into the advice category. I think I see and interact with a lot of people who are very skeptical of AI. And I think that's, to an extent,
Mm,
that's like rightfully so. You should be skeptical of AI, and especially skeptical of like the advancements that people are promising. But I think that you should also just lean into it and embrace it to a certain extent, even if it doesn't feel like the most natural thing to do, or even if you have a lot of suspicions about it. No matter how you look at AI, there is some value to be derived from it, and there are things to learn from it, and there are ways
hmm
that you can use it in a positive way. There's also definitely downsides, and there's things that it's not good at, and there's ways that you can use it for bad things, for
mm,
sure. But I think that's true of any tool, and I think people get caught up a little too much on the philosophical questions around it. And at the end of the day, we're not going to be able to fight it. I mean, we're looking at
mm,
basically the next industrial revolution, right? Like anyone who is fighting AI now is going to be seen in history the same as the people who were fighting the machines in the industrial revolution, right? That is what we're looking at fundamentally. So you can fight it and try and push it off, but I believe at this point it's inevitable. And if you embrace it and lean into it, I think that you'll be uniquely positioned to not only be able to use this stuff better and more competently in the long run, but you may also find yourself in a situation where you are able to help define the future of how human and AI machines and systems interact. And I think that that's very important.
yeah, I think John Henry was a great story, but we ended up with steam engines, and he died in that story. So, it's going to happen. And I think we could probably help ourselves. The creepy thing that I think that people get creeped out by AI is we spend so much time trying to make it human, where I think we probably would do ourselves a favor by like leaning in, as you're saying, where AI can do things that we can't. Like, don't try to make it human. Try to make it do the things that we can't do. Our perception is limited by what we can see and hear and taste and all that. It's not limited by those things, at least not directly. So let's let AI really take over where we would fall short, and we can be complementary of one another. This has been great. It was a great conversation. Happy to have you on anytime. This is fantastic. Thanks to the staff and all the folks who make this podcast possible. Thanks for tuning in to the /podcast, where bold ideas shape what's next in IT. If you enjoyed today's conversation, subscribe, share, and above all, stay curious. Until next time.